Same tree, different order. In order means at every node, we handle the whole left subtree first, then the node itself, and only then the right subtree. The node sits in the middle of its two children, which is why it is called an order. Let's see what sequence that produces. Again, we use recursion, but we shift when we output the value. For any node, we first run an order on its left child, handling the entire left subtree. Then we output the node's own value. Then we run an order on its right child. The empty node is the base case, where we simply stop. Because the value comes right between the two subtrees, the root of the whole tree is printed somewhere in the middle. On our tree, the order is 4, 2, 5, 1, 3. If the node is empty, we return an empty list and stop. Otherwise, we build the answer as the full in order of the left child, then this node's value in the middle, and the full in order of the right child. Left, self, right, and recursion does the rest. Let's write an order and run it on the same sample tree. The base case first. An empty node returns an empty list, so the recursion can stop. Otherwise, the whole left subtree, then this value in the middle, then the whole right subtree. Now, let's test it and hit run. There we go, 4, 2, 5, 1, 3. Notice how the root, 1, lands in the middle, with its left subtree fully to its left and its right subtree to its right. For a binary search tree, this order would even come out sorted. One visit looks like this. If the node is empty, stop. Otherwise, recurse into the left child first, then output this node's value, then recurse into the right child. Left, self, right. Every node is visited once, so it is order n time for n nodes. The extra memory is the recursion stack, as deep as the tree is tall, which is order h, the height of the tree. 3 things. First, handle the empty node first so the recursion can end. Second, the value must go between the two recursive calls, not before both and not after both, or you change the traversal entirely. And third, a nice fact. On a binary search tree, an order hands back the values already sorted.